Hey students, this is lesson 10.4, perimeters and areas of similar figures. We are going to learn how to find the perimeter and areas of similar figures. The main concept here is how you go from a scale factor to the ratios of perimeters and the ratios of areas. All right, go ahead and do this review. I'm going to pause. You can check back with the answers. All right, I'm going to go through this with you. It's important that you understand the relationship between the scale factor and the ratio of the perimeters and the ratio of the areas of similar figures. So what we're going to do here is pick, we're going to draw a 3 by 4 unit rectangle, then draw 3 different rectangles, each similar to the original rectangle. And I'm going to use the sizes, so my original is my 3 by 4. I'm just going to scale that up to a 6 by 8 and a 9 by 12 and a 12 by 16. If you want to go ahead and draw those on the grid provided, you can do that now. And you can do a couple ways. So here's my 3 by 4. I could shade that in. My 6 by 12 is twice as big as that. I could just create a do that, so it includes the black one and the red one. Then my 9 by, that was the 6 by 8. My next size is a 9 by 12, so that's that rectangle. And my biggest rectangle is a 12 by 16. So that's this one here. All right, and then we're going to fill in the perimeters and areas here of these, and just look at how they're related. So my perimeter of my 3 by 4 is 14. My area is 12. I'm going to pause here and just fill these in. If you want to go ahead and fill them in yourself, you can. All right, now we're going to do the scale factor. For the original, the scale from number 1 to the original, the scale factor is 2 to 1. From number 2 to the original, the scale factor is 3 to 1. And from number 3 to the original, the scale factor is 4 to 1. Now we're going to look at how the perimeters, the ratio of perimeters. So the original one is 14, and the first one is 28. So the ratio is 28 to 14, which simplifies to 2 to 1. The second one, we would go from 14 to 42. That's 3 times the perimeter, so that's 3 to 1. And the last one is 14 to 56, that's 4 times bigger, so that ratio is 4 to 1. Now the ratio of areas, don't fill these in too soon because this does change a little bit here. Notice that when we go from the original to number 1, we are 4 times bigger. So that ratio is 4 to 1. From 12 to 108, that's 9 times bigger, so that's 9 to 1. And from 12 to 192, that's 16 times bigger. So that's 16 to 1. So how do the ratios of perimeter and ratios of areas compare with scale factors? And here's the deal. Let's get a little room in here. Let's say we have a scale factor. So our scale factor is, say it's equal to A over B. Then our ratio of perimeters are exactly the same. So ratio of perimeters are also A over B. But our ratio of areas is, and notice this here, that our ratio of areas is the ratio of the scale factor squared. So if the scale factor is 2 to 1, then the ratio of areas is 4 to 1. When the scale factor was 3 to 1, the ratio of areas was 9 to 1. So we're going to say it's a squared over b squared. All right? And that's information is given in this theorem, perimeters and areas. The name for the ratio of the length of one side to the length of the corresponding side of a similar figure is the scale factor. If the scale factor of two figures is 1/2, then the ratio of their perimeters is also 1/2. If the scale factor of two figures is 3 over x, then the ratio of their perimeters is 3 over x. If the scale factor of two figures is 3 over 5, then the ratio of their areas is 3 squared over 5 squared. And the last one, same thing, you have to square them when you get the area. All right, so those are the ideas we're going to use to help us do these problems. So finding ratios in similar figures. All right, so the rectangles are similar. The ratio of the lengths of the corresponding sides is 6 over 8, or 3 to 4. What is the ratio of the smaller to the larger of the perimeters? Well, just as a reminder, if the scale factor is a over b, then the perimeter ratio is a over b also, and the area ratio is a squared over b squared. So the ratio of the perimeters would be exactly the same, 3 to 4, and the ratio of the areas would be 3 squared over 4 squared, which is 9/16. All right, I'll let you try that. You can check back for your answers. All right, the area of the smaller rectangular hexagon is about 127.3 square feet. What is the best approximation for the area of the larger regular hexagon? We're going to use the scale factors to help us out here. We know from the smaller to the larger, the ratio is 7 to 10. And so we also know that the areas, so that's the regular scale factor, then the area scale factor would be 7 squared over 10 squared, which is 49 over 100. And I know that the ratio of areas are going to equal that, so I can just set up a proportion here. And since the 127.3 area corresponds to the smaller of the two hexagons, I'm going to put that right here. And then I'll just put x there. So now I have 49 times x is equal to 100 times 127.3. And that's equal to, simplifying that, 12,730. Then we will just divide both sides by 49, and we get about 259.8 square feet. All right, I'm going to let you try that. All right, problem 3, we're going to apply these area ratios. So it will cost Maria $150 to have carpet installed in a room that measures 12 feet by 10 feet. At this rate, how much would it cost her to have carpet installed in a similarly shaped family room with a larger dimension, 18? So we have two family rooms. One is, say, 12 by 10, and the bigger one is 18 by something. We could figure that out if we want, but I don't know that we really need to know that. So our scale factor is going to be the same because they're similarly shaped. And since we're talking about covering the room with carpet, we're talking about area. So my scale factor is equal to 10/16, which simplifies to, or 10/12, sorry about that, which is the same as 5/6. And so if that's my scale factor, then my ratio of areas is going to be the scale factor squared. So 5/6 squared, which is 25/36. And this cost of $150 is for the smaller room. So I can just, so the cost for the larger room should be proportional to that. So I'm just going to write a proportion, 150 over x, x being the cost of the larger room. And so I get using cross products property, I get 25x equals 150 times 36, and 150, so I'm going to divide both sides by 25, and I get x is about, maybe exactly $216. All right, I'm going to let you try one of those. All right, finding perimeter ratios. The areas of two similar figures are 32 square meters and 50 square meters. What is the scale factor? What is the ratio of the perimeters? All right, remember, so if we have a scale factor and say it's A over B, then the ratios, corresponding ratios of perimeter is the same, A over B, and the ratio of areas is A squared over B squared. Well, in this case, we're given areas, 32 and 50, so our A squared over B squared is equal to 32 over 50. Now, to figure out what A is, one way we could do is just take the positive square root of both sides if we did that here. And remember, with square roots, you can do, you need to do the square root of the numerator and the denominator. So when I take that square root, I get A over B, and that makes sense. A over B times A over B is equal to A squared over B squared. And then I need to do the square root of 32 over 50. And I'm just going to simplify that. Square root of 32 over 50, I'm going to simplify the fraction. That's the same as 16/25. And now we can do the square root. That's the square root of 16 over the square root of 25, which is 4 over 5. And that's our scale factor, and also our ratio of perimeters. So 4 over 5 for both of those. All right, I'll let you try that. Here you're just filling in the reasons. Go ahead and do that. You can check back with your answers. All right, lesson check. The area of one rectangle is twice the area of another. What is the ratio of their perimeters? How do you know? So if x and y are the sides of the smaller rectangle, then the area of a larger rectangle is 2 times that. So the ratio of the larger to the smaller areas is 2 to 1. And so now we need to find the square root of that ratio. So the square root of 2 to 1, which is equal to the square root of 2 over square root of 1 is just 1. So there's that ratio. So the ratio of the perimeters is square root of 2 to 1 because the scale factor is the same thing. All right, that's it. I'll see you tomorrow.